and welcome back to our lessons, and in this lesson we will actually look at factorial notation. Now, in our previous lesson we looked at the basic counting principle, which told us that, and please remember this because the basic counting principle tells us that if you have a certain amount of options for your first choice and you have a certain amount of options for your second choice, you just multiply the amount of options, right? Okay, but in this case, we are going to learn about the factorial notation, which is written as an exclamation mark, and you have this little sign on your calculator as well. Now, we use the factorial when a certain number of things, let's call those amount of things n, must be arranged in a row. Okay, so important. We use factorial notation when we want to arrange things in a row. So then we can say it can be done in n factorial ways. Okay, and this is our rule number 1. Now, it's so important that you please remember, just like with the basic principle, what is the basic principle? When can we use it? The same with factorial notation. When can we use it? When we want to arrange a certain amount of things in a row. So let's look at an example. You have 4 books. Let's call them A, B, C, and D, okay? In how many different ways can we arrange them on the shelf? So we can put them in different orders on the shelf in a row, right? And because we want to arrange them on the shelf in a row, we can use the factorial notation. So there's 4 books. So basically what we do, we can do it in 4 factorial ways. Now this basically means the following: 4 times 3 times 2 times 1, okay? But you don't have to calculate this. You can just simply, on your calculator, you press the 4 and then you go and look for that little exclamation mark on your calculator, okay? And you can easily find that, and you will press the second function button, and then you press that factorial button and you press equal, and then you will get an answer of 24. Okay, now on your calculator, or at least the one that I'm using, it's always a button. It's a yellow one at the top, so not part of the main function. That's why you have to press shift first. It's a little button that shows you an X and an exclamation mark like this. Okay, so you press 4, you press second function, and you press that one, and it will give you the answer for the factorials. Okay, now example 2, consider the following one. Consider the word sand, okay, S-A-N-D. How many different words can be made from these 4 letters? So we want to rearrange these letters in different ways, okay? It doesn't matter if it really makes a word that we understand, but how many different words, whether if it's a real word or not, but we just want to rearrange all these letters in different ways. So how many different ways can we rearrange those letters? Well, that's easy as well. We've got 4 different letters, and again we want to arrange them. So again 4 factorial, which then will be equal to 24. Got it? Okay, brilliant. And please remember, this is rule number 1. But now, what if some of the things that we want to arrange in a row are repeated? Okay, so that means basically we are going to repeat some of them, or some of them are actually the same. We can still make use of the factorial, but because there is more than one of the same thing, we use the following. Okay, so basically there's many different letters, for example, in a word, but some of the letters are exactly the same. What do we do then? Well, basically we use rule number 2, which says n factorial, which is the total number of things we want to rearrange, divided by r factorial. Now, what does that r mean? It is the number of things that are repeated. Okay, and this is rule number 2. Now, if you're still confused, I think the best way to remember this is with an example. But now, after the example, please don't forget that when do we use rule 2? It's when we want to arrange things in a row, but some of the things are repeated. Okay, so 2 different rules for 2 different situations. Okay, so here's the example. Determine the number of permutations. Now, permutations in English, it actually means the number of different groups, okay, that can be formed with the letters of the word abracadabra. Okay, so how many different groups or how many different words can be made with all these letters? Now, as you can see, we've got 1, 2, 3, 4, 5 A's. We've got 1, 2 B's. We've got 1, 2 R's. Okay, so some of these letters are repeated. Okay, but the first thing we need to do is count how many letters we have. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so first thing, we write down 11 factorial because that is how many letters are in the word. And remember, we want to rearrange them in a row to make different words. So there's the 11 factorial. But we cannot use rule number 1. We're going to make use of rule number 2. Why? Because some of these letters are repeated. Okay, so we are basically going to divide with 5 factorial. Okay, now why 5 factorial? Because there's 1, 2, 3, 4, 5 A's. Okay, then we're going to multiply that with 2 factorial. Now why 2 factorial? Because there's 1, 2 B's, and then there's also 2 R's, so we are going to multiply with another 2 factorial. Okay, so basically n factorial is all the different letters or all the different things that we want to arrange in a row. We divide it by the things that are repeated. Okay, and if there's more than one thing that are repeated, we put them in their groups and we put the factorial next to it, because there's 5 A's, so 5 factorial, there's 2 B's, 2 factorial, and there's 2 R's, so 2 factorial. Okay, and remember to multiply this at the bottom, because that's what it means to put them next to one another. And then when you type this in onto your calculator and you're also using the fraction button, don't forget you have to put in the multiplication signs there. Okay, and then once you get all of that onto your calculator and you press equal, you will get 83,160. So that is how many different words can be made with the letters of abracadabra. Okay, 83,160. Okay, got it? And do you know the difference between the two rules now? Excellent. So let's go and try some more examples. Now, what if we change our previous question a little? How many different words can be made from the letters of abracadabra if the first and last letters must be an A? Okay, so that first and last one will stay an A. Okay, they are fixed. They cannot be moved. They will not be rearranged. So that leaves us with 1, 2, 3, 4, 5, 6, 7, 8, 9 letters that can be rearranged in a row. So that means from our example or our rules from before, we also know that we take the total amount of letters that can be arranged and we divide it by the ones that are repeated, right? So this is actually rule number 2, because some of the letters do repeat itself. So we will use n factorial divided by r factorial, depending on how many different letters there are that are repeated, right? So basically, therefore, we will make use of this rule, rule number 2, and now there will just be 9 letters that we will rearrange. Now, why 9? In our previous example, we had 11. Yes, because we rearranged all 11 of them. In this case, we're just rearranging 9 of them, the 9 in the middle, because the beginning and the ending letter has to stay an A. Okay, so now we divide by the number of letters that are repeated. And please remember that the A and the A are fixed. They are not part of this calculation. So basically, in this 9 that we rearrange, there's 1, 2 B's. So we put here 2 factorial times, and then there are 1, 2 R's, so times 2 factorial again, times, because now there's 1, 2, 3 A's, so times 3 factorial, and this will give us an answer of 15,120. Okay, and that is all there is to it. Now, let's change the question again. How many different words can be made from the letters of abracadabra if all the A's must stand next to one another? Okay, now this is quite important because now we bunch up all the A's. So all the A's go together. So that kind of makes one group, okay? They will not be rearranged. They move together as a group. So basically then we have just the A's as a group, so it's 1A, okay? Actually 5, but they're bunched together, so it doesn't really matter because they will not be rearranged among the other letters. So we count the A's now as one group, so it's just 1. Then we have 1, which is all the A's, 2, 3, 4, 5, 6, 7. Okay, so this will now be 7 different letters or groups that we are going to rearrange. So this will be 7 factorial divided by, now in that 7, how many things repeat itself? Remember, the A's won't repeat itself because they're all bunched together. So again, we have 1, 2 B's, so that's 2 factorial times, and how many R's? 1, 2 R's, again times 2 factorial, and that is all there is to it. So that gives us 1,260 different words that we can make if we bunch up all the A's. They form one group. Okay, so do you see what we do when we bunch the A's? Because we're simply moving them as a group. Okay, now let's look at this final example. From the above examples, what is the probability that a word starting and ending with the letter A will be chosen randomly? Now, it's so important that you understand this question because we want to know the probability. So I'll start off by writing out our first question from before, right early on in this video. I had a question where we said, if we rearrange all the letters of abracadabra, how many different words can we make? And we said that it was 11 factorial divided by 5 factorial times 2 factorial times 2 factorial. You remember that, right? And that was equal to 83,160. Okay, brilliant. Now, it's so important to understand this question. Now, what if we take all the different words that we can make from abracadabra, and there's 83,160 of them, right? And we write all of them, each one on a small piece of paper. We throw it in a box. What we're actually asking you is, if you put your hand in that box and you draw one of those small little papers, what is the probability that the word that you choose will start and end with the letter A? Okay, so there's 83,160 combinations. There's 15,120 of them that start and end with the letter A. So you remember from before, what is probability? So the probability of starting, and I'll write here, starting with A, starting A, and ending with A, okay? That will basically be the 15,120 because that's all the outcomes that we want. We already know that's the amount of words there are that can start with an A and end with an A. And we divide it by the total outcomes for rearranging all the letters from the word abracadabra, which is 83,160. So 83,160. And when we are busy with probability, we always want to write our answer in the simplest form, which will be 2 over 11. That's the same as 0.18 as a decimal. Please go through this video one more time. Make sure you know the difference between just n factorial and the difference between n factorial divided by r factorial. There's 2 rules. We apply them for 2 different situations. Make sure you remember them, and see you next time. Bye. This is your host Richard T, and thank you for joining us. Please visit our website mathsa.co.za for free guided exam tutorials.